Hey, if you're building APIs for systems like payment, inventory, webhook, or orders and more, idempotency keys are very important for you. Because systems like this usually sends the same request more than once because the user Wi-Fi might drop or the browser might time out or the server might return an error causing the retry. And without a guard, these retries count as a new action and might affect your system in a way you're not imagining it. Maybe it's like another payment debit in your payment system, another order creation, another email or SMS, which can have impact on your price, security, and more. The solution here is using idempotency keys. Because idempotency keys tells your server that, hey, this particular request is of the same action which is already existing, so please treat them as one. And in this video, we'll actually see what is idempotency keys and how to implement it and how they help in building a resilient backend system. Sounds exciting, right? Let's jump into it. Okay, before we jump into the code, I wanted to show you the demo of what we're gonna be building, okay? And actually show you the safe and unsafe version of it in action so that it will build up some interest. Okay, so let's see. The first thing is let me refresh the page. Okay, so we have a sender and the recipient over here. Basically, it's a simple payment application and a list of users with their balance. Okay, and we have safe and unsafe demo. Safe uses idempotency keys and unsafe doesn't. Okay, you can ignore parallel safe. It's just running things parallelly. Okay, now let's select the user. I'm going to select Alberto and Carlin over here, and you can see their user list was selected. And just keep an eye on the balances. Okay, so it's $154 and $105. I'm going to send $10, okay, from sender to recipient. I'm going to do unsafe demo. So what happens here is we will send the first request, then the server errors out, then we keep on retrying until it's successful. Okay, and this demo I've made sure that we retry 3 times. Okay, so the server sends an error 3 times. Okay, meaning 3 retry and 1 the first request, so it's 4 requests in total. Okay, so I'm going to send the demo, and you can see attempt 2, attempt 4, it was successful. All right. And if I scroll down, you can see the balance was debited 4 times. It was $154, now it's down to $114. Okay, which is a serious issue in case of payment applications, right? Because the intention was just to send $10. Now let's try safe demo. Again, the balance is 114. We send the safe demo. So attempt 1, 2, 3, and then 4. Okay, and the payment was successful. And if I scroll down, the balance is 104, which is correct. The safe demo used idempotency keys over here, which is simple UUID. This makes sure that the backend is resilient against these retries, and no matter if you send 100 retries over here, the result would be the same because of the same idempotency keys. Sounds exciting, right? So let's see how to implement this. All right, now that we saw the demo, let's jump into the code. So before we write the code, let's actually plan what are we going to do. The first thing is we'll be building an unsafe API, okay, which doesn't have idempotency keys and which is vulnerable, okay, and then we'll actually add idempotency keys and then make it safe, okay, make sure it's resilient against these retry attacks, okay, and then also we'll go one step ahead and make sure that no matter how many requests we get in parallel, meaning we'll simulate multiple users requesting at once, and also check if our server or if our APIs is resilient against these multiple requests coming in all together. Okay, this is the plan and it's very exciting ahead. Let's jump into the code. All right, welcome to the code. Okay, the first thing is I have a simple Express setup already done. Okay, so that will save time from all these installation setting up and everything. And the next thing is there are 3 important things you want to know in this setup. The first thing is it's a simple Express setup, nothing more, nothing less. The second thing is we are using LowDB as a database over here. It's a very tiny package. It uses JSON as a database. You can see all the user list over here that you saw in the demo. And this is very useful when you're building demo apps or very quick MVPs and everything. Very quick, very safe. Okay, it's really cool. It's type safe as well. Okay. And the next thing is utilities. The first utility is validation. You have API validation already done over here, like body amount is equal to 0. Then we throw an error, all this stuff, basic stuff. And the next thing is ops. Ops is really crucial here. The reason is, remember that we're trying to simulate the error, right? We're deliberately trying to throw an error and then deliberately making the client to resend the request, basically retry the request. And what hiccup count will do is, it will track the amount of time you've thrown the error. Okay, remember in the demo, we got the error thrice, right? And we are tracking that number, that is number 3, using this hiccup count. So for every request, when we throw an error, we keep a count tracked over here. And when it reaches the number 3 or more than 3, we'll perform the actual logic and return success message. Okay, and that's the reason we have some utility functions like, hiccup count, get hiccup count, reset hiccup count, and all this stuff. Cool. Now moving to the server.ts, and also we have client index HTML front end application, the one that we saw the demo app. Okay, that's over here, and you guys will be able to get the code. It will be in the description. Okay, you can check it out. Moving on. Now that we have everything ready, let's write our API. The first API is unsafe API. So let's write that. So we'll declare the API, and then the first thing we'll do is add error handling. Okay, so whenever you're working with async APIs or asynchronous functions, make sure the first thing you would do is error handling. Okay, and whenever working with APIs, the first thing you would do is add input validation. Okay, validate the input before you do anything. All right, the next thing is we'll actually get the request body, and then they'll get the balances from the database. And after this, before we move forward, we have to make sure the sender and the receiver actually exist, and the sender balance is more than the amount, correct? That's what we're going to do. We're going to check the sender, we're going to check their balances, and then we'll check their, I'm going to zoom in a bit. Yes. And then we check the recipient, okay, if they exist or not. Okay. And then we create some utilities like transfer ID. I'm using random UUID over here, but feel free to use anything you want, but make sure it's always unique. Okay. And a new balance variable to store the new balance here. Okay. Now that we have it, let's update the database. Okay, so we're going to do db update, and then I'm going to get the sender and the receiver. We'll check if the sender and receiver actually exist. Okay, if yes, then we'll subtract the amount from the sender and then add the amount for the receiver. Okay, basically the receiver balance. All right, and then we're going to create a transfer, basically a new transfer record saying that a transfer or transaction just happened. All right, and then we'll update the new balance. We'll just say, hey, everything is done. Here's the new balance. And at this point, okay, at this point over here, the balance is updated of the receiver. Okay, and then we'll create a hiccup. Okay, because we want to show the debit, right? We're going to show the explicit debits happening in unsafe APIs. That's the reason once everything is updated, we're going to throw an error saying that, hey, something went wrong. Okay, for that, we're going to create a hash of sender, receiver, and then the amount. When you combine these three things and create a hash, it's always unique. Meaning that if you send the same request over and over again with the same sender, same receiver, and same amount, you will get the same hash no matter how many times you try. Okay, that's the beauty of hashing. Okay, we'll use the hash as the key, and then we'll get the hiccup count, current hiccup count. So if the hiccup count is more than 3 or equal to 3, we'll actually say reset the hiccup count for this key, and then say, hey, it is completed. Okay, the transfer is done. If not, if it's lesser than 3, then we'll add the hiccup count, basically update the count. Okay, and then return, hey, might have to server is unavailable, you might have to try again. Okay, and then return. And of course, add error handling. Very simple, right? Very straightforward. All right, recapping, check the balances, check the users exist, check their balances, then update the DB with the transactions. Okay, and then create a hiccup key using hash so that it's always unique. I mean, unique in a sense for every single request. Okay, and if it is more than 3, we return successful, else we return service unavailable, please retry. This will trigger the front end to retry. Okay, cool. All right, the next step is to create safe API with idempotency keys. Let's go. All right, now let's write the safe API. The first thing we do is define the safe API, add try catch block as usual, add error handling as usual, add input validation as usual. Okay, cool. These are the basic thing which is done. The next thing we would do is something pretty new that is called concurrency handling. What is this? So remember in the demo or while explaining the other things, we mentioned that we'll handle parallel request as well. Meaning that if multiple user sends multiple requests at the same time, we'll handle that too, right? Basically the parallel safe in the demo. That's what's called as concurrency. Okay. When you're getting multiple requests at the same time, that's concurrency. And since Node.js is single threaded, there are different strategies to handle that. And in this case, I'm using log. Okay, log is a package basically from async log. I'm using that because it abstracts all the complexity for me, and it's very easy for even for the demo as well. So to show it to you guys, it's very good starting point. Okay, just to get the feel of the concurrency, and then maybe moving on, you can implement your own strategy. Cool. So we'll start log acquire. So we'll tag that with the idempotency key we're getting. Okay, and then we'll actually create a payload hash, same as the hiccup key, hash the sender, receiver, and the amount. Okay, to get the unique hash. Then we'll get the database, and then we'll try to get the snapshot. So what is snapshot over here, and why are we getting that with idempotency key? So remember that when we're discussing about idempotency key before, what we said is our action is debit and credit, right? And we have to make sure that we only do this once, no matter how many times we send the request, right? And so what snapshot does is, the safe APIs will take a snapshot when the first time the request comes in, the new request comes in of the action, and tag that with the idempotency key. And every single time you make a retry request, it will check if the snapshot exists or not. If it does, it will understand that the operation is work in progress and it will not touch that again. Okay. So you just say, tell the server that, hey, it's processing, try again. Or maybe server is unavailable, retry. Something like that. Okay. That's what snapshot is. Very simple thing. Cool. Now let's assume that the snapshot exists. That's the first case we'll handle. The snapshot exists. First thing we'll check is if the snapshot payload hash is equal to the payload hash we just created. This is very important because you want to make sure that nobody is messing up with the different payload. Let's say the attacker sends the first request with amount 10 or amount 100 or something, and with a unique idempotency key. And let's say they take the same idempotency key and then maybe change the amount or change the sender or something. Maybe they change the recipient. Okay, from Alice to Bob to Alice to David. Okay, now if you don't check this, you would still treat that as a valid request and then maybe credit and debit to a different account. Okay, which is very bad. That's the reason we verify that if the payload hash is also valid or not. Okay, after that, we're going to get some details out of the snapshot, the state, attempt count, and transfer ID. Okay, the first thing we'll do is check if the state is complete. Okay, let's say 3 attempts are over. Now it's time to say successful. Then we just say, hey, everything is good, it's completed. Okay. And the next thing is if the state is pending. What do we do if it is pending? The first thing we do is we'll go inside DB update, okay? Because we want to update a couple of things, right? We want to update the attempt count, how many attempts have been made. We're going to update the balance and everything, right? So the first thing we do is we'll check if the attempt count is lesser than 3, then we increment the attempt count. That's the first thing we do. Hey, is it lesser than 3? Increment it because it's a new request. And if it is greater than or equal to 3, let's say I'm sending my retry request, the final retry request, okay, which is obviously equal to 3 or greater than 3. Then we'll mark the state as complete for the snapshot as well as the transfer record. Okay. And then we'll increment or credit the amount to the receiver or the recipient. Okay. And then we update the timestamp. When was this finalized? Cool. Then we come out of this DB update. I'm going to collapse this because just for the proper view sake. Okay. So when we come out of this DB update, then we check if the attempt was the attempt count lesser than 3 or greater than 3. And then we respond to the client. You cannot do this inside DB update because this DB update is a transaction in database. Just Google database transaction, you'll understand this. Okay. And you cannot usually send the server response from inside. So you have to come outside and do it. Okay. That's the reason once we are out, we're checking if the attempt count is lesser than 3, then we just say service unavailable, please retry. And then we also return idempotency key as well over here along with the response. Okay. If it is not lesser than 3, obviously it's greater than or equal to 3, right? Then we just say get the sender and then we'll just say, hey, here's the new balance of the sender and here's the transfer ID. Everything is done. It's completed. Okay. And that's it. So this is what we do if the snapshot exists. We just check, okay, if the snapshot exists and if it's pending, we increment it. If it's done, we just return the data. All right. Moving on. Let me collapse if condition as well over here. So now let's assume that the snapshot doesn't exist at all. So it's a new request. The first thing we do is we get the sender, we check their balance, we get the receiver, we check if they exist. Same thing as we did in the previous API. Okay. And then we create transfer ID and new balance. Again, same thing we did in the previous API. And the next thing we do is DB update. This will be kind of similar to the previous API, but with slight twist. Okay. So first thing we do is get the sender balance. Okay. Check if their balance exists or not. I mean, if the sender exists or not. Okay. And then we debit from the sender. Okay. Then create a transfer record, say it's pending. We didn't credit the balance yet. We just debited it. Okay. We just say, hey, it's pending now. Okay. And then set the new balance of the sender. Also create a snapshot. Okay. With the payload hash that we created in the top, the idempotency key that the client sent us in the request, the transfer ID, this one, the state pending, attempt count is 1. This was the first attempt. Okay. Then we just return to the server saying that service unavailable for some reason, please retry. Straightforward, right? Just a few updates and then that's it. So for the fourth, once you actually retry 3 times, you will be able to get the success response and everything. And this will make sure the debit only happens once. Unlike the unsafe API where the debit happens 3 times. Okay, very straightforward, right? It was not complicated at all, correct? A few extra lines of code, of course, I agree with that. But with idempotency key, it made it very resilient. Okay, and you can see we didn't implement all these complex systems here, caching and other stuff. Okay, which is not bad actually. It depends on the requirement and the plan. But with just a simple extra property called idempotency key, we were able to make it resilient. Okay, cool. And let's run the server. My server should already be running. Let me just stop this, clear it, run it again. Okay, and if we go to localhost 3000, my browser is in a different window. Let me get it for you. There we go. We should be able to get it. Okay, so I'm gonna select Alberto, Emera. Okay, 150, 132. Send $10. We'll do parallel safe this time. You can see my 5 requests converged into 1 unique transfers. So many things happening, and the balance was debited. Okay, and if you do safe demo again, where is it? Upwards. Payment was successful. You can see 134. And let's do unsafe demo. We should see 104 if I'm not wrong. Oh, it's 4 times, of course. First request and then 3 retries. The total 4. Yes. Okay. So everything works flawlessly. Okay. This was the demo on idempotency keys, guys. And you might ask me, all these things that we just learned, where will this be even helpful for me, right? In day-to-day job. Not in terms of just hypothetical theory thing. Where is this helpful for me in day-to-day job? Let's discuss that. So let me tell you one thing. So if the first thing is, there are some project requirements which will have this listed by default. Let's say some senior engineer is drafting the requirement. They might list this idempotency key in the implementation guidelines, okay, which will make your life easier because it's already there, so you just implement it. Some might not, okay. Usually this is considered as a non-functional requirement, okay, or security implementation or security improvement, okay. So what you have to do is, you have to by default develop the skill to analyze the requirement and make a judgment call. Okay, make a judgment call based on how the entire data flow is happening. Okay, is this a critical system where one action should happen only once, no matter how many times it's been invoked? If yes, then idempotency keys are required there. If not, then no worries. Okay, so think about the system, think about the requirement. If yes, make a call. Okay, by default, if you want to take a textbook here, then textbook definitions are like payments, order systems, inventory management, all these need idempotency keys. Okay, any application that deals with healthcare, financial, files, or downloads, all these things need idempotency keys. Okay, there are some use case that doesn't, so it's up to you to make a judgment call. All right, so with that said, thank you so much for watching, guys. Okay, and do follow us on every single social media we have. The link is in the description. We keep posting these amazing things, and you have no idea how many things we have planned for the future. Okay, this will be an amazing journey with us. Okay, make sure you follow us on social media. Thank you so much. We'll see you in the next one. Bye.